Welcome to today's tutorial. So in this tutorial we're going to be solving a question from Thomas exercise from Thomas calculus textbook about the slopes and tangents. So this is exercise 13 to 16. So if you have not yet subscribed to the channel, make sure that you do so by clicking the subscription button, and also don't forget to click the notification button. And if you have any questions, make sure that you contact me on any of these lines. Okay, so let's quickly begin to solve. Okay, so the question says, in this exercise, or in exercises 13 to 16, differentiate the functions and find the slope of the tangent line at a given value of the independent variable. So every time you're finding dy dx, or the derivative, the first derivative, you should know that you are finding the gradient function. So when you find dy dx, or in other words dy dx or f prime of x, this one is equal to the gradient function. So this one is known as the gradient function. Then they're asking us to find the slope, which is just the gradient. Okay, so when they ask you to find the slope, they're simply just asking you to find dy dx. Okay, so let's quickly begin to solve. So the first one is f of x is equal to x plus, of course 9 over x can also be written as 9x to the power negative 1. So to find the gradient function of this expression, we find f prime of x. So when you differentiate x, the answer we'll get is just 1. Then when you differentiate this other part, negative 1 times positive 9, the answer will be negative 9. Then we have x to the power negative 1 minus 1, the answer will be negative 2. So this one can also be written as f prime of x is simply just equal to f prime of x is simply just equal to 1 minus 9 over x squared. So this is what you're going to have as the gradient function. So they're asking us to find the slope at this given variable, value of the independent variable. So we can find the slope by replacing the value of x while there's x there. So we say f prime of negative 3 will now be equal to 1 minus 9 over negative 3 squared. So this will just give us 1 minus 9 over 9. So f prime of negative 3 simply just giving us what? So 1, this will be 1 minus 9 over 9, the answer is 1. So 1 minus 1 is simply just equal to 0. So the solution for the first part is simply just 0. Let's move on to the next one. So the next one is 14. So I'm going to do 14 and probably even 16. Then you do 15. Or I will leave 2 for you as well. So we can, so in case you want the videos where I've explained how to use product rule, quotient rule, chains rule, and also other rules, and the power rule, other rules of differentiation, you can just contact me. I'll send it over to you so that you revise that even before watching these other tutorial videos. So for this one, we have k is equal to, we have kx is equal to 1 over 2 plus x when x is equal to 2. So at x is equal to 2 rather. So to find the derivative of this, we know that this is this can also be written as 2 plus x to the power negative 1. So if you want, you can just use this one and use quotient rule to find the derivative, or if you want, you can just use this one and use chains rule to find the derivative. So when you use chains rule, k prime of x, which is the gradient function, will simply just be equal to, we say negative 1 times the coefficient this side is simply just negative 1 times 1 is simply just negative 1. And then we say when you differentiate what is inside here, what is inside the brackets, you're just getting 1 as the answer, because the derivative of 2 is 0, the derivative of x is 1. so we multiply it by that, then we write the whole expression the way it is. Have 2 plus x, then we have negative 1, we say minus 1, so negative 1 minus 1 minus 1, we're getting negative 2. So let us write our gradient function. So k prime of x simply just equal to, so this would be negative 1 times negative, times positive 1 is negative 1, times that, just get the negative of this, so this would be 2 plus x, and of course raised to the power negative 2. So this is our gradient function. So our gradient function will be k prime of x is equal to, then we have negative 1 on top. Since this one is negative, we'll make it positive by taking it down as a denominator. So we have 2 plus x, then we say this is raised to the power positive 2. So this is our gradient function. So now to find the gradient, which is the slope, we say k prime of x at x is equal to 2 is equal to, so we just replace 2 while there's x there, so we have negative 1 as a numerator, then down there you have 2 plus, while there's x we put 2, then we say squared, so this will be equal to negative 1, then everything divided by 2 plus 2, that will be 4, then 4 squared, the answer will be 16, so we have negative 1 over 16 as the answer. Okay, so this is the expression for the gradient function, and then this is the solution for the slope. So this is the slope. Okay, so there's also this question. I'll do this one, then you do this one as a practice exercise. So for this one, we've been taught to differentiate this one to find the gradient function for this expression, which is the slope function. So the slope function will be s prime of t. So in this case we're using t, s prime of t so is equal to, so s prime of t is equal to, so we differentiate t to the power 3, this will just be 3t squared. We also differentiate t to the power 2, which is just going to be 2t. So to find the gradient, you just replace negative 1 while there's t. So when you put negative 1 while there's t, here negative 1 squared, the answer will be 1. 1 times 3, the answer will simply just be 3. Then we also say when you put negative 1 there, this will be negative 1 times negative 2, the answer will be positive 2. So the slope for this one is simply just 5. So this is how you deal with such questions. So thank you very much for watching today's tutorial. If you have not yet subscribed to the channel, make sure that you do so by clicking the subscription button, and don't forget to click the notification button so that you'll be notified whenever I post any video on my channel. My name is Harmtedy. See you in the next tutorial video. Shalom, shalom.